Hello, this is Sebastian Moore, and this is my final project for Databases Management and Design class, SEIS 630. I hope you enjoy and that you learn something new. So before I get into my topic, which is federated machine learning, kind of wanted to talk about the problem that it's solving. So typically, machine learning algorithms are built off of training data that are collected from users individually and then stored on one centralized server where a model is trained and then deployed. Now, an issue with that, and just to provide an example here, I have autocomplete texting, which I'm sure you've all used at one point or another. Um, in order for a company like Apple to deploy this machine learning model, which is what they use for that product, they would have to collect individual users' text messages and conversations, which is a huge privacy risk and then also a control risk in terms of what type of information they're getting, what type of information they have access to. And I'm sure most of you wouldn't want a large corporation looking at your text messages or having your private data. It's also pretty inefficient computationally. And any issues with that centralized server will throw down the whole network. So if you think about Christmas lights. Um, some other solutions that have been proposed would be to just train on your individual device, but really with just one user, there's not enough data to build a powerful model. Also pre-training a model, but then that can become outdated quickly. Say if there's a new phrase or word that was integrated in this example. So what is the solution and basically what is federated machine learning? So how federated machine learning works is rather than you sending your data to a company or a centralized server, um, the machine learning is actually done on the individual server or on the individual device. So in this case, with the autocomplete messaging, the machine learning would be being performed on your phone. That way, the results of the model, the hyperparameters, the weights, the formulas, those are then returned to one centralized server without having to share any individual data of yours with the company. So they don't get any of your text messages, they just get the high level results from the machine learning model that was trained on your individual phone in this case. Those results are then aggregated with every other user in the network to create a very powerful, accurate model. And that model is then used on your device to make those predictions. So that way you get the privacy benefit of not having to share any of your data, but you also get the benefit of kind of getting everyone else's data to build a more accurate model. So it's a win-win for everyone. And this is just kind of a diagram outlining that process in a different way. So how does this relate to concepts learned in class? Joins and relational databases. Obviously, these have to be, if the data is coming from several different databases, has to be joined together to aggregate that machine learning model. Using primary and foreign keys. Typically, federated machine learning is done on the cloud. When the models come together and are centralized, database redesign. If you have a traditional machine learning model, it will take a large redesign in order to shift that to a federated model, and that may take a lot of standardization and aligning on schemas and keys, things like that, to ensure that the data is compatible across multiple users and companies. And then anonymization, just making sure your data is anonymized using some of these techniques that we may or may not have learned about, just to keep everything safe and secure. So on to the fun stuff. How is this being used today? Medical field is huge. If you think about hospitals and their data, they cannot release patient data because it is private, obviously, which means they're only limited to the data from their hospital. But if you use federated learning, then you can use data from hospitals across the world to build one model and help predict disease better. And you can see an example of that right there at University of California, San Francisco. So that's really cool. Google is similarly to Apple with the phone example is using it to improve its voice recognition system training. So that's really awesome as well. And then financial institutions such as banks, I think this is a big one. Obviously, banks don't want to share customer data with other banks, but also every single bank wants to stop fraud. So if US Bank can get together with Wells Fargo and put their data together to make an even more powerful machine learning model that can detect fraudulent transactions without having to actually share customer data and put that at risk, then that is a win-win for everybody involved. So some of the challenges and what is ahead in the future for federated machine learning. So increasing regulations around data privacy and security, since federated machine learning is obviously heavily reliant on user data. It will need to make sure it's keeping up with those. Otherwise, it won't have many other options. Also, some users and companies still may not be comfortable, even though there are measures in place to ensure this privacy. They may not fully understand it and they may choose to opt out of it because they don't see the benefit. And then for business to business examples, like I mentioned with the bank, it does require cooperation between many different parties, which could present its own set of legal financial challenges and sort of rivals maybe not wanting to work together. So overall, I see that federated machine learning will have a large future with the growth of AI, and I'm looking forward to see what comes next. Thank you for watching my project and hope everyone has a good rest of your night.